and welcome to the Daily Space Weather. There's a coronal mass ejection headed our way, and lots to talk about. We're going to do a cosmic ray report, and the, as you may have come to expect, most comprehensive daily space weather and detailed solar imagery you'll find in the known universe. Let's get to it. Some plasma motions happening here around the eastern limb. That's why we highlighted this area. The coronal mass ejection came from down here. It was part of the Alex Lifeson filament. Yeah, we've been naming filaments after living people. Here is the northern polar region. You can see a little crown prominence up there, a feature that will become more and more common as we ramp up and up and up to solar maximum over the next 9 to 10 months. So you can expect at least these levels of solar activity, maybe even higher. So there's a sweet series of frames from the western limb, and we have to say farewell to that setting sunspot, although it still does pose some risk for producing X-class solar flares. That will wane throughout the day today as those huge arching loops of plasma move out of view of the Earth. And just a quick reminder, folks, don't conflate solar flares with coronal mass ejections. These are separate phenomenon. We see one without the other one all the time. Solar flares are photons. In other words, they are X-rays. Coronal mass ejections are protons, massive gas blowing out of the solar corona. Here's the southern polar region, a prominence down there as well. Also a view of the Bellafleck filament, which is this one over here. And let's don't forget the Alex Lifeson filament, which is this one over here. By the way, if you want to name filaments after living people, why not join us over on Twitter and just follow the hashtag #NameThatFilament. More about that later in the video. Here is yesterday plus today in SDO intensitygram. We do have some modest growth there in the northeast and some decay in the southern hemisphere. Here is your colorized magnetogram for yesterday plus today. At least yesterday plus today to date. And just so you know, there are paid promotions linked below this video. Please visit our description to visit our paid promotion links. Let's see what's going on for volcanoes. Here's what's been happening in the past 24. Volcanic activity starts out the list with Mount Mayon producing an unknown volcanic ash plume on the Isle of Luzon, Philippines. Central Mexico featuring Popocatépetl exploding at 23,000-foot ash plume size there. It's a flight level 230, flight level 250 over Colombia from Nevado del Ruiz. Sangay in Ecuador exploding, flight level 210. Flight level 150 over Revenador. Sabancaya exploding, flight level 240. And the world's most active earthquake at the moment is in Peru. It's Ubinas as it explodes. It's producing a flight level 270. That's a 27,000-foot plume of volcanic ash. Please do not pole vault the caldera. Next, looking at the past 90 days of seismicity to see it's calm for the past 24 hours. Very low number of earthquakes, and no big earthquakes and not many earthquakes, period. Of the quakes of a 5 magnitude or higher, they only include a couple here, like this 5.2 south of Sandwich Islands. That was at 12:01 Universal Time yesterday on, quote, Independence, and quote, Day. South of the Kermadec Islands, there was also a 5.2. That was at 16:05 Universal Time yesterday afternoon. And those are the only 5+ magnitude quakes, folks. Again, it's been very calm, seismically speaking. Let's get back to space. Here's ionized helium. Once again, these are all 24-hour videos from SDO, the Solar Dynamics Observatory. And yeah, that's some pretty sweet imagery, wouldn't you say? Here we've added 171 angstroms to it. Another 24-hour video here from SDO. So let's talk additional features here, like the 10.7 centimeter radial flux and so forth. So the 10.7 centimeter radial flux is now at 168 solar flux units. We've made this animation just to sweeten the pot here. That radio flux comes from this portion of the sun right here, the upper chromosphere and lower corona. A little thin strip there, right at the bottom of the solar atmosphere. So there you go. There is the 1-year graph of the radio flux. That is from solon.info. And if you're paying attention, you can see how similar that line is to the red line, which is the sunspot number. And let's take a look at the CMEs. The CME, the coronal mass ejection that is headed our way. So occasionally the sun blasts off massive portions of gas out of its corona. And there is one headed this way. We're expecting it to arrive sometime after noontime on July 7th. So this is NASA's forecast. See that little bubble coming out there? It is a little bit to the east. And the Parker Solar Probe there moving in between Earth and Sun, represented by that green square. The fastest object ever built by mankind, the Parker Solar Probe, moving at hundreds of kilometers per second at its fastest speeds. Next, the NOAA forecast. And NOAA forecasting a similar thing there. Also an impact there sometime around midday or later on the 7th. Actually, NOAA forecasting that a little bit earlier to arrive, but hey, it's close. So when everybody agrees to this extent, you can expect the coronal mass ejection impact forecasts to be correct. If NOAA, NASA, excuse me, I don't know if I inhaled cayenne pepper or what happened. When NOAA, NASA, and Tamitha Skov and Smash-O-Mash all agree on the CME impact timing, you can expect it to be accurate. It's pretty unlikely for NOAA, NASA, Tamitha Skov, and our channel to all agree and be incorrect. Although I haven't seen Dr. Skov's forecast yet. Here you can see NOAA forecasting barely even geomagnetic unrest there. We could see as high as a KP7. It all depends on the magnetic field. So tough to forecast what the magnetic field is going to be like, but a large portion of that CME should hit, and the impact should last quite a while there, probably over, I'd say, maybe 10 hours, 12 hours, something like that. We could see as high as a KP7 from that. And remember, folks, you got to over-forecast these sorts of things. Like, there's a reason why weather forecasters forecast, more snow, harder hurricane hits, and so on. It's because, well, it's because of being responsible with forecasts, period. So let's take a look at Earth's magnetic moment from space, and you may see an interesting wall of plasma showing up here at the end. Keep in mind, this is a model, and it is based on all kinds of different features. So it's based on the electron flux, ground-based magnetometers, space-based magnetometers, the solar wind density, solar wind speed, magnetic fields, and lots more data sets. At the end of this video, you'll see a huge increase in the solar wind density here, represented by magnetohydrodynamic pressure. This depicts the last 4 hours of magnetohydrodynamic pressure. And right here in the last few minutes, you see that huge density wave showing up there. That is typical of a coronal hole high-speed stream impact. So those are typically preceded by a high-density wave of plasma. That is not the end of the world you're witnessing there. That is just an uptick in the solar wind density. So there it is. The end is still not near. Little uptick in the solar wind density there. So here is the ground magnetic perturbations map. This is Earth's magnetic moment from the ground. We showed you Earth's magnetic moment from space. Here it is from the ground. This depicts magnetic flux density as opposed to magnetohydrodynamic pressure. On the last video, it is also 4 hours. And you'll see a huge uptick here on the ground level as well. Keep in mind, this is based on the same model, the Space Weather Modeling Framework, University of Michigan Geospace Model V2.0, and you can read all about the variables used in this by clicking the Details tab on the ground magnetic perturbations map. So that was a pretty minor thing there. It looks extreme because of the gradient. It is not extreme at all. The KP is only 1, and it could even be erroneous data here, but it looks like it's legit. So anyway, there you go. KP1, planetary K index, is a global average of geomagnetism. KP1 is a geomagnetically calm condition. And fun fact, we're going to show the cosmic ray report today because it's been a while since we did one, I think even over a week. So we'll have to do that. Next, the real-time solar wind here, and this is this little density spike you saw there. And that could be like a little CME impact, actually. It does look a bit like one, as there was a high-speed section. I'm trying to zoom in on that. Let me just change the timing here. We'll switch this to the last 2 hours. And we're getting a heap and helping and nothing with that. How about the last 6 hours? See if we can get a reading on this. So the speed went up to, speed went up to 629 kilometers a second. Density went up to 48 protons per cubic centimeter there for a brief period of time. Could have been a CME impact. That would be the best guess. Sometimes there are little sporadic, stealthy CME impacts that are very hard to forecast. Anyway, it was short-lived. That was data from the ACE. Now we're back to just about the levels that we were before, although we are seeing an increase in the density there as well. So this could be an early onset coronal hole high-speed stream impact. Again, those are preceded by a high-density wave, and we are seeing indeed an increase in the density. No major change in the magnetic fields, though. So could be a coronal hole high-speed stream here, showing up a little early than expected. Current conditions are about 10.3 protons per cubic centimeter for the solar wind density. Solar wind speed 342 kilometers per second. And here comes some more data. The GOES magnetometers are next. And those are pretty unremarkable. Let's take a look at the heliospheric current sheet, which is always remarkable. So there you go. There's the heliospheric current sheet. And there is a sector boundary crossing headed this way. It is the sector boundary crossing from the north of the South Pole current sheet for Earth's potential field surface source lines. There you go. See that red area coming? That is the South Pole current sheet. So there you go. There's the South Pole. The south magnetic pole of the solar system is approaching. The north magnetic pole of the solar system is going to be out here within the next about 48 hours. I'll say about 36 hours. I expect to still be in a North Pole current sheet by tomorrow's video. Here is our line of sight field plot. Basically turning the sun 90 degrees and looking at it from Earth's view instead of from the polar view. There you can see the sun's B field in blue, north polar field in green, south polar field in red, and the gong magnetogram in grayscale. And here's our line of sight coronal hole plot. We do have a South Pole coronal hole infiltrating here. So South Pole coronal hole popping up there in the northeastern limb. And let's take a look at coronal holes from the perspective of SDO. So there is SDO, 211 angstroms wavelength. Quite a cavernous coronal hole there. There's a closer view of that. Again, we may be seeing some early onset coronal hole high-speed streams. Keep in mind these things don't just come out in a straight line. The coronal hole high-speed plasma comes out in like a spiral shape. Keep in mind the sun is rotating at a very high speed. Great view there of a coronal hole. Anyway, moving to sunspots. Yeah, sunspots. So there's the current situation. There is one new sunspot to get a name. It is down here in the southeastern limb. Besides that, things are pretty stable here. So we'll I'm going to show sunspots here in a couple different views. So this is an interesting one where we've put together a 24-hour SDO video featuring 304 angstroms ionized helium and the magnetic fields. So you can see how there's a lot of white there around the high magnetic field areas. The sun is known to produce a lot more helium around solar maximum than around solar minimum. And you can see that in effect right there, a lot of white depicting a lot of ionized helium there. That's the 304 angstroms wavelength. The rest of that is the HMI instrument showing the magnetic fields of the photosphere. So here we switch to the HMI continuum. This is the sort of what you call the full spectrum wavelength of the photosphere, and that's going to show sunspots. Let's subtract the 304 angstroms to show higher sunspot detail. So some degradation in the southern hemisphere, moderate, mild growth in the northern hemisphere. Besides that, no new active regions here besides this alpha class sunspot over here. This is a pretty boring sunspot at the moment. It does not harbor complex magnetic fields. But there are several sunspot groups that do indeed harbor complex magnetic fields. Hence, they're more likely to produce large solar flares. So we're going to get to the cosmic ray report here in just a moment. First, let's take a look at the GOES proton flux. So these are energetic particles that come from the sun. And the GOES proton flux here not featuring any spikes. So these are called solar energetic particle events. They are associated with large solar flares. And we haven't seen one in an extended period of time here. Let's take a look at the X-ray flux. But before we do that, let's take a look at the cosmic ray report. So cosmic rays are a different type of energetic particle. They come from outside the solar system. In fact, they can even come from outside the galaxy, and it's very hard to know where a cosmic ray comes from. Cosmic rays are a part of space weather, and they are inversely proportional to the sunspot number. So when you have lots of cosmic rays, you have low sunspots, and when you have lots of sunspots, you have low cosmic rays. The more significant the solar cycle is, the lower the cosmic ray flux gets at solar maximum. So let's take a look at this inversely proportional solar data set, cosmic ray flux. So there's a Patates neutron monitor. You can see over the past 30 days a significant downtick, although holding steady for the past about 10 days. Barentsburg, also a similar graph there. So you can see a downtick over the past 30 and quite steady over the past 10 days. Let's go farther south to Athens, Greece. A similar graph there, a downtick over the past 30 days, stable over the past 10 days. Mexico City is next, looking like a similar graph there. So data corroboration is a good thing, folks. It indicates that it is legit. There's a downtick over the past 30 days and a steady past 10 days for cosmic ray flux at Mexico City. And we'll go back up north to Oulu next. Similar, but less of a variation there. A downtick over the past 30 days. I would also note, if you look right here in the graph, solar cycle 25 has gone lower than solar cycle 24 for cosmic ray flux. And you can expect that to get even lower, as this is a more powerful cycle than solar cycle 24. It's a much stronger cycle, featuring much more of everything: coronal mass ejections, flares, sunspots, higher radio flux, etc. And let's go as far south as we can get. Antarctica, the highest, driest continent. Again, a similar graph there, a downtick over the past 30, steady over the past 10 days. DOMC Antarctica, a similar graph. So that's the cosmic ray report. It is a downtick for the past 30 days, steady over the past 10 days, and the forecast is expect cosmic ray flux to continue to decrease. If you're relying on that for the end of the world, well, your end of the world forecast has been canceled. Canceled. Cosmic ray flux is going to go down, not up. Deal with it. Enter into reality if you're forecasting doomsday based on some cosmologic nonsense. Next is the GOES X-ray flux. This is the X-ray output of the closest star. Yeah, solar flares. Again, don't conflate them with coronal mass ejections. Solar flares are photons. CMEs are protons. Once again, a flare happening as we produce the video. Shout out to the sun once again. Thanks for leaving a comment here in the form of a solar flare. That is the that is a C7.58. And it looks like a double peak, possible long duration. Let's take a look at this closer up here. More like a triple peak, staying just below the M-class level. Peak flux has been so far C7.42. And let's bring up one of the favorite wavelengths to view solar flares. We like 94 angstroms as well as 131. What the heck? Okay. I'll just click on it and nothing will happen. Wonderful. Anyway, here's 94 angstroms. That is yesterday plus today. And allow me just to pause for station identification. Congratulations on realizing the Smash News Network least busted name in news exists. We're frankly surprised. And give those a minute to load because that is well worth it. All right, sweet. The site can't be reached. There we go. So there is the 94 angstroms wavelength, which is depicting yesterday plus today to date. We have multiple large magnetically complex sunspots, so the likelihood for large solar flares remains quite high. We'll just say that. Don't be surprised to see M or X class flares. There are multiple locations to see those. Next, we'll bring up a star chart because we want to see what's going on overhead. And this is relevant to some people. They might be forecasting, I don't know, their astrology or something. If you're viewing the dusk sky, highly recommended. The dawn sky, well, if you're up before dawn, you'll be able to see Saturn and Jupiter and the setting full moon there. If you're viewing the dusk sky, you'll be able to see Venus and Mars very close together there on the ecliptic. Venus just south of the ecliptic and Mars just north of the ecliptic. The path the sun takes across the sky, so have a look at that if you are up around sunset. Two very bright planets there. Speaking of planets, this is where heavenly bodies are today, and we'll advance this 1 week for your solar system forecast. Some people think the planets are in control of the sun, so we challenge them by showing this stuff every day. It's just that planets aren't in control of the sun. It's quite the opposite. And I'll just leave it at that. No, the barycenter of the solar system does not determine sunspot activity. It doesn't determine solar minimum or solar maximum or anything like that. It's just a claim that people make. I guess they don't read the scientific literature. I have read lots of it, and I'm done reading it until something worth reading comes out about it. Anyway, here's your solar system forecast, and hopefully you're not believing nonsense about Jupiter and Saturn or something like that controlling the sun's activity. It's idiotic. There's your 1 week forecast. That's where things will be in a week. To all you heavenly bodies out there, we will have a crescent waning moon by then. And let's take a look at some CMEs. Yeah, some CMEs. So obviously there's one on the way. And here is some sweet imagery of it. So that is yesterday's imagery, and you can see that CME coming Jesus. Wow, I got to learn how to speak the English language today. Mainly coming out of the southern and eastern hemisphere. This CME is quite earthly directed here. It's only off a little bit to the east and a little bit to the south. We are expecting an extended CME impact. And again, we could see as high as a KP7. If I had to bet, I would say KP 6.33. A mild to moderate geomagnetic storm could be triggered by this. It all depends on the magnetic field intensity. So that's 72 frames from yesterday. Here are some frames from today. 36 more frames there. And it doesn't look like anything else is piling on here. Let's take a look at some more coronagraphs. So there is Soho Lasco C2 and C3. And it looks like things are pretty chill here. Now, we've taken stereo A as well, and we've put together a video of that. Feel free to pause the video on this frame if you're not familiar with the locations of the solar orbiter, Bepi-Colombo, the Parker Solar Probe, Venus, stereo A and B, etc. And here we've paused. So we've paused the video on this frame because this is 8 o'clock yesterday morning. So here you can see, here's stereo A. There's that CME. There's some missing frames there, about 4 hours worth, but you can see that CME propagating, headed right toward stereo A, which is very close to Earth at the moment. And here is Soho Lasco C3, same deal. So it's almost a full halo eruption. I mean, it's a nearly directly earthly directed CME. We'll just say that. And since then, no major activity. So let's look at our custom coronagraphs here. Here is the past 24 hours in composite, Soho, Lasco C2, and C3, and the SDO 193 angstroms wavelength. By the way, the likelihood of additional coronal mass ejection is very, very high. So likelihood of continued coronal mass ejection activity and likelihood of solar flare activity very high. We'll talk about filaments here in a minute. First, a slightly more zoomed in view. And there is a bunch of plasma instability happening right on the Earth-facing portion of the solar disk now. So that is one of the features that is associated with driving flares and coronal mass ejection activity, plasma instability in the solar corona. There are all kinds of ways to forecast this stuff, folks, and it is not magic. It is not psychic powers. It is not because the sun is sending me psychic messages, although maybe it is. Here's just 193 angstroms by itself. Again, some plasma instability kicking up. And let's take a look at filaments here, because filaments are a big deal. So these are huge expanses of a complex soup of molecular material there, suspended by magnetic fields in the solar corona, defying gravity. All those dark regions you see there on the Earth-facing portion of the solar disk are huge plasma filaments. This one here is the Bella Fleck filament. This one over here is the Alex Lifeson filament, the lower portion of which is headed to Earth's direction. So that'll be the Alex Lifeson geomagnetic storm when that strikes on the 7th. This one back here could use a name. That would be my next one to name, although we do have a series of filaments up here, and we do name them after living people. Let's do a quick demo here. If you want to name filaments yourself, just follow us over on Twitter. Follow the hashtag #NameThatFilament. And thanks to everybody who's followed us on social media. Pardon all the pathetic, putrid, disgusting, and fascist censorship on all big tech platforms. You know, the country's been going down the drain since about 2011. That is when the internet started to die because of rampant censorship by big tech organizations. By 2011, I stopped using Google as a search engine because I realized it doesn't work. It does not return objective search results. It returns biased search results. And by 2015, the U.S. was officially a banana republic. So RIP the U.S., the free press was dead by 2015, and it's only gotten worse. The past 3 years have been truly a horror movie in terms of overreach and so forth. Let us know in the comments what you think about the last 3 years. Here are the past 2.5 hours from the GOES 18 SUVI, ionized helium. And we do have a massive plasma filament hanging out there in the northeast. So crown prominence is at both poles, plasma filament at the northeast, and a continued likelihood of X-class solar flares. So that's a thing. And let's move on to show some more custom videos, because we like to be thorough when it comes to the space weather, as there's certainly a lot of aesthetically pleasing data to show daily on the channel. The Smash News Network. It's real news, not fake news, not corporate nonsense, and not catastrophist propaganda backed up by zero science. It's facts. Yeah, facts. Yeah, so that's the past 24 hours there. We've got 193 plus 304 angstroms. And while we're here, let's show the 171 angstroms wavelength by itself. It's the house favorite wavelength. That is from SDO, and that is one of the many species of ionized iron depicted by the Solar Dynamics Observatory. Good stuff there. And let's get to our bonus feature segment, starting with the Satellites Community Dashboard. Yeah, we showed you the Space Weather Enthusiast dashboard. Here comes the Satellite Community Dashboard. And we see some internal charging hazards here. That is on the dark side of the planet. Those internal charging hazards caused by high-energy electrons, which have a tendency to get into the internal circuitry of satellites. That is in the southern Indian Ocean here, moving toward Africa. Could cause some minor communications breakdowns. Goes electron flux here remaining in warning levels. That's the past 3 days from the radiographic measurements by the GOES 16 and GOES 18 from their geosynchronous near equatorial orbits. Here's the 1-year graph to put it in context. It's an electron storm and it's continuing. This is going to subside today. Here is the relativistic electron forecast model, and NOAA forecasting a little dip there. I would tend to agree. I think it's going to be even lower. I think it's going to be down here. So, and then if we do have a CME impact, it could get even lower there, as the ionosphere puffs up when space weather shows up. Anyway, feel free to pause the video on this frame because we're going to show the F layer of the ionosphere next. Yeah, the F layer. It's at about 300 kilometers of altitude right here. And that is where those relativistic electrons are measured. Here's the vibrational frequency of that slice of the atmosphere there, the bridge between Earth and space, the F layer of the ionosphere. Everything looking pretty copacetic there. Nothing to write home about. Ionosphere receives my seal of approval for the day, which is fortunate because I have no control over it, and neither does HAARP or mankind in general. Here is the ionospheric anomaly from the 30-day median, depicting high-frequency anomalies in blue and low-frequency anomalies in red. And no major issues happening here. At the moment, it is, again, pretty calm here, despite a little uptick in the solar wind density over the past few hours. Here's the latest image. That is 11:15 Universal Time ionogram, depicting raw megahertz. And there is anomalygram depicting megahertz anomaly from the 30-day median. We also like to show total electron content because this is one of the features that would go haywire if Earth's magnetic poles were actually flipping, which, by the way, they aren't, or there is zero indication that they are, because it would show up in the space weather data. Guess what? It doesn't. Here's a total electron content forecast depicting free electrons from GPS satellite level to handset level, which is a run of about 12,500 miles. And if there were huge issues happening with the magnetic pole flipping, if we were seeing a real geomagnetic excursion and the Earth's geomagnetic fields were super, super weak, then this would be all over the place and it would be all chaotic. It isn't. It's fairly orderly, despite some anomalies there in the southern hemisphere. It's fairly orderly. An indication that for all of you folks hoping that the world is ending, sorry, world's still not ending. There is some more proof of it. We show it daily on the channel because apparently it is controversial. So because there are so many catastrophist channels who are like, the world is ending, quick, buy my bunker supplies. Here's a total electron content anomaly from the 10-day average, and we are seeing some high electron count anomalies here over the Caribbean, Mexico, the Gulf of Mexico, and the East Pacific. So there are some high electron content signals. There's the highest one. Little anomaly from the 10-day average showing up there. Well, let's play that through one more time and then show the latest high-res images of the closest star. So there's what's going on. Total electron content anomaly. And there is the intensity gram. Let's press refresh just so you know that you're getting the latest So as this group sets, it still does have the capability to produce X-class solar flares. As long as you can see those huge plasma loops, you could see a large solar flare. This group down here is beta gamma delta class, just barely. This group up here is beta gamma class. This group here is beta gamma delta class, just barely. And again, we'll have one more new named sunspot group today, at least this one right here, which is alpha class, a magnetically simple sunspot group. Most likely places to see large flares is the northern hemisphere. So all of these groups up here still harbor the kind of magnetic fields likely to produce M or even X-class solar flares. Let's move on to meteorology. And we're going to talk about hurricane forecasting here for a brief moment. I think I've demonstrated on the channel many times that I know how to forecast hurricanes because I understand atmospheric physics, which is basically the wall between you and being able to forecast your weather. If you understand atmospheric physics, you can forecast the weather. There's plenty of data to do it. If not, you probably can't forecast the data. So, you probably can't forecast the weather, regardless of how much data you have, because knowledge is the key to these things, folks. So anyway, what we're showing here is Saharan dust. All right, all of this dust, this is the DUX. It's depicting aerosol thickness 550 nanometers. And that dust tamps down systems. So that's one of the features that you can use to forecast earthquakes, to forecast hurricanes. There you go. Saharan dust, this tamps down systems. This prevents convection and makes tropical systems weaker. Another thing that makes them weaker is high pressure zones. So here's another fine example. This is depicting surface winds as well as dust. And you can see this clockwise rotation for the northern hemisphere there. That is an anticyclone. So that means that there's high wind shear emanating from that H. All right. Wind shear also destroys hurricanes as it breaks up the upper level clouds and prevents them from building into a strong convective system. Next, the other thing to look at is ocean temperatures. So if you look at ocean temperatures, there is sea surface temperature. And the raw temperature is more important than the anomaly here. So there's the anomaly, and there's sea surface temperatures. So for example, if a hurricane takes this track, it's going to have a higher tendency to produce major activity than if it takes this track, where it's getting over cold water, as opposed to this extremely 90-degree water around the Caribbean and Gulf. So those are sort of the three major factors that you can use yourself if you want to do some hurricane forecasting. So far, it has been a mild year, to say the least. Let's take a look at the surface winds and the rest of the winds from around the planet. So this is the surface wind scenario for the eastern world. A strong low there, just south of Australia there, creating some high winds in the southern part of the country. Also a strong low there around the Aleutian Islands. Here are the jet streams of this side of the planet. Jet streams of the west. Surface winds of this side of the planet. And here is the central world. And here are the jet streams. Next, an animated pressure map from windy.com. There is the global pressure map. Got a strong low there hanging out in the southern Atlantic Ocean. Also the Southern Ocean. It's wintertime down there, featuring some pretty nasty looking lows. Next, clouds and fog over the U.S. and South America. Bunch of low clouds there over the southeastern Pacific. There you go. Clouds and fog over the U.S. Some strong cloud cover there over Missouri. Here is your weather map from weather.gov. Yeah, weather.gov. That is the National Weather Service homepage. We've scrolled down to show you the key. That's about the most we can do here, as there are a lot of counties lit up. Some heat advisories, red flag warnings, etc. Get your weather warnings at weather.gov, and here come some forecasts for the lower 48. So there you go. There's pressure and precipitation. That is the GFS 72-hour pressure and precipitation forecast. We show 3-day forecasts on the channel because they're accurate. And if you think mankind can forecast the weather for 50 years, keep in mind that mankind can't forecast the weather for 4 days accurately. So we show 72 hours. Here's the jet stream forecast. And I just want you to notice this, the way the jet stream correlates with weather. Yeah, because the jet stream pushes weather systems from west to east. There's the jet stream forecast, represented by the GFS 72-hour 250 millibar wind speed. There you can see that cold air intruding from Canada, creating pressure gradients at the edge of that jet stream. That's not a coincidence, folks. That is one of the many features that you ought to be able to forecast that should, if you understand the physics of, allow you to be able to forecast your weather. We hope you're able to. Last but not least, temperature anomaly, based on the same model, the GFS 72-hour temperature anomaly forecast in degrees Celsius. Moving right along to our lightning mapper. There is the past about 10 hours of lightning. We'll briefly show a real-time lightning map from lightningmaps.org. And quite a bit of lightning here over Western and Central Europe. Some quite active cells there. But it looks like it's clear for the Tour de France today. Let us know in the comments who you think will win the Tour de France. My guess would be Tadej Pogačar of Slovenia. Next, if you enjoy the content, don't just press like and subscribe. Come visit our websites. We've built a massive web ring for people just like you. And by the way, we are against all censorship. Yeah, we're free speech purists. We encourage all legal speech, even comments that are idiotic. So if you've got an idiotic comment, please leave it. Just keep in mind that you might be berated in the comments, and we will not ban, mute, block anybody. It's not a thing that we do. That is evil and fascistic, and we don't do it. Censoring people leads to a bad place. So if you're on a slippery slope, why not recognize it and get off the slippery slope? Just saying. Ever heard of unintended consequences? Are you an utter moron? Are you not familiar with unintended consequences? Well, so many people are that they do idiotic things constantly. We don't do that at the Smash News Network, least busted name in news. We cite facts, and those are controversial. You can find our homepage as well at smashomash.com. If you want additional content, join the Smash team, though, smashomash.com/Smash team. We just put up a post just this morning for Gold Smash Team members only, and if you want to know what that's about, well, you owe us $9.99. Today's featured product is Universum Liberate. Now, I'm independent, all right? I'm not a shill for anybody, because if I was a shill for somebody, it would be easier to get paid than attempting to organize a dinner between a blue whale and a falcon. Did you know I have a record label? Yeah, it's called Golden Cat Productions. You can find us all over the internet. Original tracks, Golden Cat Productions. Our record label founded back in the year 2000. And we say to you today, Universum Liberate. It's the motto of the Galactic Federation Special Forces. Do you want to be a part of the Galactic Federation Special Forces? Well, why not advertise for the unit, the regimen, whatever you want to call it. Sorry, the regiment. Regimen your throw blanket with the regimen. Universum liberate. It's Latin. If you don't know what it means, it means free everybody. If that's too reckless for you, sorry, we're free speech purists, and we do not tolerate censorship. If you've got a wrench, by the way, because you're viewing the live comments, the live premiere chat, don't try to censor anybody, because if you do, we will find you. We will shame you and make you pay. Accountability always comes. So join the Galactic Federation Special Forces with the handsome logo here, and tell your friends and foes, Universum liberate. Maybe they'll think you've joined the Illuminati, and that'll be cute. That'll be cute, folks. Anyway, we'll close out the video with Doppler radar and U.S. weather. So there is the U.S. Doppler. It shows vertical motion in the air column. There's the lower 48. Here is clouds and fog over the lower 48. And here is water vapor. Again, you can see cold air there intruding from Canada, creating pressure gradients. You've got blocking features down here. Yeah, blocking features. See, this is high pressure. So the four corners right now, there's clear sky over the four corners. And over here you've got a relative low. It's not a super low, but it's a relative low. Here you've got more high pressure. And, you know, you've got this cold air kind of making its way down like this from Canada. And I don't know, that's what's going on. Here's your recap. U.S. Doppler radar map. It's a value-added service as we put your space weather and Earth weather together. There's clouds and fog. Forecasting the weather is too easy. I discovered this like 20 years ago, and that brought me to space weather forecasting, which is almost a challenge. It's almost a challenge. It's more like a bodily function these days, as most of this stuff is pretty wired, folks. It's not controversial. These are just facts, which are controversial because reasons. Anyway, since facts are so controversial, and I've made the Earth such a scary place by citing so many facts, I'm going to go back to the bunker before the world ends, because I'm very spooked by space, by facts, and by the amount of fraud that is promoted on the internet and on media in general. So anyway, back to the bunker with me, and good luck. In the meantime, may that solar wind be at your back. Whoa!